Thought I'd do a quick little video here. These rubber bushings here, I know I've got them squeezed fairly good there, but I think they'll work really well. Anyway, this is a NAPA part, 650-1113. This is what it looks like. It is rubber. That way I don't have to deal with the grief and the hardness of urethane, which is kind of nice. So, as you can see here, you know, I'm getting some pretty good articulation there now. It's not real hard or binding or anything like that. Time to tell on the vehicle, basically, once I get it assembled, whether or not that gives too much fore and aft. I haven't, can't quite tell. You know, when you're twisting it like that, it pinches and flexes pretty nice and stuff like that, but when you actually pull straight and it has to compress it solid, I think it'll be pretty darn firm. So on this side here, well, let's go back to here. That hole is the one that I reamed out. So it is just about big enough to fit that extra lip in there. You know, the original hole, we'll go over here now, the original hole is basically this size right here. That's brace off the other one. Wow. And the battery's almost dead again. Jeez Louise. So this is a 1/2-inch piece of tubing. I think I got it from Home Depot with 1/16 wall. So basically what I'm looking at is the option here of making a sleeve, okay, because it will fit inside there fairly nicely. But on the end I was just showing you last, the one this plate goes on, I have to drill this hole out to match that lip or cut that lip off. Most likely whatever plate is made there for the tension rod, I will just simply have the hole cut for that size. On the other end here, they may just get cut off and have a sleeve put in, and by putting in the sleeve, I don't have to worry so much about the thin 3/8 inch bar. You know, this is the equivalent of the size of the shaft on the end of the what do you call it? The tension control rod. Here, let's just do this. So basically, I could make a spacer, a sleeve, to go in the bushings and that stuff that would help protect that. That way, the sleeve would take the wear and the abuse instead of the 3/8 rod. And so I think that might just be the way I go. Let's go answer the phone and charge the battery. All right, I'll be splicing some of these together anyway, but okay, there's I think it'll focus down. You can see that the sleeve that I plan on using is just a little too big. Now it will fit in there. Yeah, see, it'll fit in there. What it does though is it pushes that outer ring right there out a little bit bigger, and then it doesn't fit in the hole that I drilled out. And I'm not sure I want to drill that hole out any bigger. I may not drill that hole out, period, for the final design. So 6 of one, half dozen of the other. Yeah, it doesn't quite fit in there. It does fit in here though, and that's basically what we'd be what I'd be looking at there, is whether or not to cut down that lip or drill the hole big enough, grind it out, file it out to hold that. Now, having the hole bigger would certainly be the better option, because then you wouldn't end up with any metal on metal here, you know. But I also think too that once it's all squeezed together and that stuff, it's going to grip to the point where it's not going to clatter anyway. You will get some metal on metal abrasion here, but that's part of the point of the sleeve, is that the sleeve will then protect the shaft. Okay, because I've showed this before. We'll see whether or not it'll focus here. Give it a second. You can see the damage, you know, right through here where it's hit before. Now this one's not near as bad as some other ones I've seen. So, you know, if the sleeve was went on like that, that would protect that. It would also help keep from over crushing the bushings. Yeah, I don't have an engineering degree or anything like that, so part of this is just kind of figuring it out as I go. Take the best guess, that kind of thing. You know, now there's no sleeve. This hole is all bored out, so it's not going to hit anyway. Seems there was another point I wanted to make, but that's it for now. All right, that was the other point. Was I could actually turn down the outer diameter of this tubing, and then do a cutoff. Do that with the lathe. I'm trying to avoid having to manufacture or have made any more parts than absolutely necessary. So since this fits in here so well, I think I would opt to bore the hole in the bracket to match the outside diameter of that lip right there. That way that would fit in there quite nicely and protect the sleeve and everything like that. That just might be the way. And then that way there's no modifying the rubber bushing. There's no modifying the sleeve. It would just simply be a one-time modification to the front bracket where they go in. And then what that does is that also means that then this NAPA part could be used as replacement bushings at any other time. Now this is the equivalent in a urethane. That is a sway bar bushing. Someone's knocking at the door. Oh, let's see here. Might have to retake this a little bit, but what we're looking at here is this is the 521 touch control rod arm. I have made a sleeve. Okay, this was a piece of tubing I believe I got from Home Depot, half-inch outer diameter with a 1/16 wall, so that makes it fit the 3/8 inch shaft perfectly. What it also does is it fits into these NAPA bushings quite nicely. So what I've done is I've left it just a little bit short, okay, and it's going to mount on this. I guess we can come over a little bit, try to get in the center of the picture there. Anyway, this is, I'm going to use 1/4 inch thick tab. This isn't the shape or anything like that. I'm working on other dimensions right now first, but basically there's the stock washer. I'm going to put it on like that. It came off the factory arm like that. Yes, I understand that most of the time when you put bushings on, they're supposed to be like that, but this is the way it came off, so I'm going to assume that's the way it's supposed to go back on this rig. So anyway, what I've done here is I've drilled a 13/16 hole in here, okay, and so it fits down in there beautifully, okay. So that's perfect. That accommodates the slight stretch I think I talked about in one of the other ones. There's a little bit of stretch there. If you can see that, it's just a little bit bigger. It's not a great deal. So anyway, 13/16 turned out to fit that perfect. Okay, so what we're going to do is we're going to slide that on there. Now the other one, slide it over the sleeve and into the plate there. Okay, and I'm going to go ahead and throw a washer on here, and I'm going to cheat just a little bit because I've got it handy. But okay. So that's down, that's tight against the sleeve. So I will have to find what fell on the floor. So let's see if we can get a different angle on it here. There is some movement there. Okay, keep in mind that is not touching the metal sleeve inside, and that metal sleeve is actually helping to make that bar, that 3/8 inch shaft, a little thicker and more sturdy. So I kind of like that, and that ought to give it nice and firm in that stuff. These might be squished just a hair too much. I may change that dimension slightly. This is starting to bulge on the left side here, so I kind of like the right one a little better. I may add, you know, 50 thousandths or something like that to that. Make it 1.3. Now, while I'm here, what I'm looking at is this hole is going to have to get opened up. This is the brace for the other end of the strut rod. Okay. Yeah, see, you can see that damage right there. Hopefully, I think, maybe. And with that sleeve on there, that should really help protect that from getting any worse, because the bushings would wear out. See, none of these stock bushings had the flange on them. They would have this. There's a flange on that. That flange is what would fit in the, not on this piece, it fits on the frame side. And it would sit in there, and that was supposed to hold it. The only problem is once these all got worn out, then this would slip out of the frame and that stuff, and they would bang around and grind on this piece. So what I want to do is, and I'll probably take another picture or shoot it again later, but what I'm proposing is to grind that and the frame out to the 13/16, and then the frame's a little narrower than this, but then basically I'll supply a 1/8 inch thick washer cut to basically this dimension here, 13/16 inside hole, and 1 3/8 outside. This is only 1 1/4 because I'm prototyping. I didn't have to be exact right just yet. So I want to put the extra washer on to help spread the load, since we're going to be taking some of the meat off around the hole, top and bottom. Just a rough idea there. See, this is going to get thinner now. So in order to help make that stronger, what I'm thinking is include a washer in there, and that ought to do the trick. So I think that's it for this. I still have to cut a sleeve for this one, and then mount it up on here. Basically, this measurement, whatever this measurement is with the frame and the washer and the safety saddle, whatever you want to call it. However much more that is than what I figure out on the other end for the other sleeve, I'll just add that difference and I'll cut the sleeve accordingly, and then I'll basically get the same pinch on the bushings as I have on this end. So I think that'll work. That's it for now. All right, in case I decided to just add the video and not the pictures. Basically, to show how much squish is going on the bushings here, what I did was when the nut just threads on and everything, the slop comes out of the washers and everything like that, the nut is actually flush with the end of the threaded rod here. And so that is just over 1/8 of an inch, 3/16 roughly. So we're getting about 3/16 of an inch of squish here. I don't think that's too horrible. Just a hair less might be a little better. I'll play with another sleeve and see how I like that, and go from there. Just a little. I trimmed it down. The sleeve is exactly 1 1/4 right now. I like that, so I put just a tiny bit more squish on the rubber. And basically, what I'm doing is the tip of the of that bracket. You know, I'm in about to here basically. I've got 5/8 of an inch clamped into the you know, a 1/4 inch. Anyway, so what I'm looking at here is I want to see that I can get enough range of motion without severely bending that 1/4 inch, because what I don't want to happen on the car is I don't want it to do what's called the coat hanger effect. When you bend a piece of metal back and forth, every time it flexes a little bit, it work hardens. Okay, and that sooner or later it snaps. It's called the coat hanger effect. You can take a coat hanger and bend it back and forth, you know, whatever it is, 2 dozen times, I guess, I don't know, and it'll snap. I don't want that to happen. So if I put urethane on here and tried to get this much movement out of it, it would flex a whole lot more than that. In fact, I may try that, but I kind of like what I'm seeing here. And as far as trying to pull on it, oh man, there's like you know, to do it right in line with the rubber, it's not going to do it. I think it's pretty darn firm. I like that. Now to finish setting up the sleeve for the other end. All right, this is we're working on the 521 ball joint mod. So these bushings, these are the NAPA bushings that I've been working with here. I've got enough thread sticking out on the end there. The squish is maybe just a hair more than I have on the other end. I'm really not too worried about it. Part of the reason is that there's a slight bow in the frame here, and this washer's flat. And I think after it's been beat on a couple of times and that kind of stuff, that'll settle in there a little bit. And that extra squish will just, swell out to meet it and that stuff. Everything will be okay. And that's got a sleeve in there too, so it's cranked down tight against it. This also has a sleeve in it. Now what I thought was kind of interesting here was, look at this. There's nothing supporting that. Okay. Granted, the frame is leaning. It's not leaning a great deal. The frame is leaning a little bit toward me, and that could account for some of that distance there. But I mean, we're so close. That's almost exactly where that rod wants to sit statically with the bushings. So I really like that. There's less than 1/8 of an inch there that I have to push it in. And as far as up and down, I'll just find the sweet spot right there in the middle and weld that. And my marks aren't there anymore. But that's almost, oh yeah, I can just make out the mark there. That's almost exactly right where the 10 inches is. I was measuring it and tacking it down before. So part of the reason why I redid it, cut the tacks and that stuff, is these inner bushings. It dawned on me that the distance between the frame mount and this tab would change once I changed bushings. So I figured I better get the bushings squared away first, and then go from there. And I'm glad I did, because it definitely moved the tab to the right there some. So at one point I thought the tab was going to hang over the edge here. I was going to have to redo that plate, but I don't mind that. That's okay. I like that. Keeps it nice and clean. What I may do is bring this tab up at a 90 degree like I have on the back side here, and weld the gusset on this side. I haven't quite decided. I may weld the gusset on the back side. For now, once I tack those and that, if I do put a gusset on, I'll put it on the back side. But I really like where that's sitting, so I think I'll fire up the welder and tack that on, and then I think that'll be about it for today. All right, real quick clip here. This is at the top of suspension throw. That's how much, and you can see it go through its range of motion here. That's pretty darn nice. I like that. All right, I'm at the bottom of the travel here, and let's see here. Let me try to stay out of the picture some. I'm going to stand on the frame here, and I'm going to pull on the control arm. Oh, and I'm seeing a little bit of movement at the arm. Part of it's the flex of the tab I welded on, which will go away when I finish welding that down. I'll have to go back and look at the video myself to see whether or not how much that rubber's moving. And granted, me pulling it with my arms isn't anywhere close to hitting the brakes even lightly in the truck when it's running. So let's take a look at the other bushings. All right, we'll see if it stays in the frame there. Basically, this is all the way down. No, I am not hitting here. There's still 1/16 of an inch of clearance there, so we'll run it up through the rest of the range of motion there, up at the top. I think there might be just a tiny bit of flex here in the since I'm only tack welded down. Let's see if I can. Yeah, some of that's the frame. I'm getting about 1/16 of an inch at the hub. And granted, I'm not pulling on it anywhere near like a vehicle would. You can see a little rubber compression there. So, might have to do something different. Not exactly sure yet. So, I don't mind a little flex. I just don't have any clue whether or not that's too much, too little. I'll have to weld a gusset on that tab to make sure it can't move, and then go from there. I don't have any way of checking the hardness compared to the factory ones, and can't get the factory ones anymore to test. At least I haven't looked really hard yet. Anyway, that's where it sits for now. Let's just do that real quick and run it through the range one more time. That's nice. The arm shortens it up, and you can't really see it when it's down there in the very bottom. It pulls it that way. Now, granted, when all this is put together and the spacers are in there, there'll be a little bit more flex there. But going through the range of motion, the arm is pushing it that way. The tension rod's pushing the arm that way a little bit, and I'm ending up with just a little bit more gap down there at the bottom. But sitting roughly in, yeah, see, that's just fine. I like that. Let's shove it up all the way. Yeah, that'll put a little load on the lower bushing. I don't think I'm going to worry about that too much. It's a rubber bushing. It's going to handle it just fine. But it does make me wonder, well, no. I want this all set up at ride height because that's where the car is going to be sitting. Man, I should probably script these things instead of thinking out loud on the camera. If it's going on a vehicle that's going to be even lower, then that tab might have to be moved. So what it may end up being, it might be that the holes in this plate, they might possibly get slotted just to be able to pull this arm forward a little bit more to adjust that. I thought about down here, this nut right here, it's too tight right now. This nut is for adjustment here, and you could actually run it out. I didn't want to run it out anymore. It's flush basically. It's as short as the arm will get. I thought about running it out 3/8 of an inch to 1/2 inch, but I'd run out of thread out here on the bolt because the bushings are thicker than stock. So if I find a better bushing option, that would allow me to lengthen that arm and weld the tab on, and that means the tab would weld back even further to the outside, and then you could shorten the rod up a little bit and pull that forward even a little bit more. But I don't think it's a huge issue, since the upper arm is going to be able to, you can adjust that with shims to get the caster and stuff like that. So yeah, I like where it's sitting so far. We'll just we'll call it good for the day.